In 2009, the Nobel Prize in Physiology or Medicine was awarded to three American scientists, Elizabeth Blackburn, Carol Greider, and Jack Szostak, for a discovery that fundamentally changed how science understands the aging of every cell in the human body. Their work described a structure so small it is invisible to the naked eye, located at the tips of every chromosome in every cell of your body, whose length predicts with extraordinary accuracy how quickly those cells are aging, how vulnerable the body is to chronic disease, and how many functional years remain before the cellular machinery of the body begins to fail in ways that show up as the IZs and limitations we associate with growing old. That structure is the telomere, and the discovery that won the Nobel Prize, the discovery of the enzyme that maintains and can even lengthen telomeres, has opened a door in aging science that has produced one of the most practically important findings in modern medicine. That specific behaviors, practiced consistently, can slow telomere shortening, preserve cellular youth, and in some documented cases actually lengthen telomeres that have already been eroded by time and lifestyle. One of the most consistent, most reproducible, and most practically accessible of those behaviors is exercise. But not all exercise produces equivalent telomere effects. The research has become specific enough to identify particular types of movement, performed at particular intensities, producing particular molecular signals inside the cell, that most powerfully engage the telomere maintenance machinery that Elizabeth Blackburn's Nobel-winning work brought to light. Today we are going to talk about 5 exercises you can perform in the morning before the day's demands arrive in approximately 20 to 30 minutes, without specialized equipment, that the research on telomere biology has identified as among the most effective forms of physical activity for slowing cellular aging, supporting telomerase activity, and preserving the chromosomal integrity that determines how young your cells remain regardless of the number on your birthday cake. Before we reveal the 5 exercises, we need to spend time on the science, because the telomere story is one of the most remarkable in all of biology, and understanding it is what transforms these 5 exercises from a morning workout into a deliberate act of cellular self-preservation. Every cell in your body contains 46 chromosomes, long strands of DNA wound tightly around protein scaffolding, carrying the genetic instructions for every protein your body makes. At the tips of each chromosome sit the telomeres, repetitive sequences of DNA that function like the plastic caps at the ends of shoelaces. Their job is not to carry genetic information. Their job is to protect the chromosomal ends from damage, from degradation, and from the cellular machinery that would otherwise mistake the chromosome ends for broken DNA requiring repair. Each time a cell divides, and your cells divide continuously, replacing the billions of cells that die each day in every tissue of your body, the telomeres shorten slightly. This shortening is the result of a fundamental limitation in how DNA is copied. The enzyme that replicates DNA cannot fully replicate the very end of each chromosome, so a small segment of telomere is lost with each division. Over time, over decades of division, telomeres shorten progressively until they reach a critically short length at which the cell either stops dividing entirely, entering a state called cellular senescence, or triggers its own death through a process called apoptosis. Cellular senescence is not benign, senescent cells that have stopped dividing because their telomeres have become too short, remain metabolically active and become what researchers call zombie cells. They no longer contribute to tissue repair and renewal, but they continuously secrete a cocktail of inflammatory molecules called the senescence-associated secretory phenotype, or SASP. The SASP drives the chronic low-grade inflammation, the inflammaging we have discussed throughout this channel, that is now recognized as the common biological substrate of virtually every age-related chronic disease, from cardiovascular disease to Alzheimer's, to type 2 diabetes to cancer. The length of your telomeres, therefore, is a direct measure of your cellular age, independent of your chronological age. A 55-year-old with long telomeres has younger cells than a 45-year-old with short telomeres, and the rate at which telomeres shorten is not fixed. It is profoundly influenced by the choices you make, including, with particular potency, the physical activity you engage in. Elizabeth Blackburn's co-discovery with Jack Szostak and Carol Greider was the enzyme telomerase, a remarkable molecular machine that can add new telomere sequences back onto shortened chromosome ends, effectively reversing the shortening that occurs with cell division. In most adult somatic cells, telomerase activity is low, which is why aging produces progressive telomere shortening. But telomerase activity in adult cells is not fixed. It responds to environmental signals, specifically to the biochemical signaling environment created by physical activity. A landmark study published in the European Heart Journal compared telomere length in professional endurance athletes, recreational exercisers, and sedentary adults of similar age. The endurance athletes showed significantly longer telomere lengths and significantly higher telomerase activity than both other groups. The recreational exercisers, people exercising 3 to 4 times per week at moderate intensity, showed meaningfully longer telomeres than the sedentary group. The relationship was dose-dependent and consistent. More exercise, particularly the forms most associated with cardiovascular demand and muscular metabolic stress, correlated with greater telomere preservation. A subsequent study published in the journal Preventive Medicine, specifically examining adults over 50, found that those who engaged in regular physical activity had telomere lengths equivalent to those of people 9 to 10 years younger in sedentary comparison groups. 9 to 10 years of biological age, preserved by the consistent choice to move. The specific molecular mechanisms connecting exercise to telomere preservation involve several well-characterized pathways. The first is the reduction of oxidative stress. Regular exercise upregulates the body's own antioxidant enzyme systems, including superoxide dismutase, catalase, and glutathione peroxidase, providing endogenous protection against the oxidative telomere damage that sedentary living allows to accumulate. The second is the reduction of chronic inflammation. Exercise-mediated reductions in inflammatory biomarkers are simultaneously reductions in one of the primary biological drivers of accelerated telomere attrition. The third is the direct activation of telomerase by exercise-induced molecular signals, specifically through AMPK activation, the same energy-sensing pathway we have discussed in the context of blood sugar management and weight loss, which promotes telomerase expression through downstream signaling cascades. With this foundation established, let us turn to the 5 exercises. The first exercise is jogging or brisk walking. The telomere benefit of aerobic exercise is most documented at moderate intensity, an effort level that elevates the heart rate to approximately 60 to 75% of maximum, produces perceptible but manageable breathlessness, and can be sustained for 20 to 30 minutes without stopping. This is the intensity range most consistently associated with the oxidative stress reduction, anti-inflammatory signaling, and AMPK activation that produce telomere protective effects. For adults over 50, brisk walking, at a pace that produces noticeable elevation in breathing but allows conversation, achieves the target heart rate range without the joint stress of running, and is fully supported by the research on telomere preservation. 20 to 30 minutes of brisk walking in the morning, performed with enough pace to feel genuinely challenged but not uncomfortable, delivers the aerobic stimulus that activates the molecular pathways connecting exercise to telomere maintenance. This is the single most accessible, most broadly documented, and most practically sustainable exercise on this list. The second exercise is high-intensity interval training, known as HIIT. A clinical study published in the European Heart Journal, a dedicated comparison of HIIT, continuous aerobic training, and resistance training in older adults, found that both HIIT and continuous aerobic training increased telomere length and telomerase activity, with HIIT producing the most significant improvements in telomerase activity of the 3 exercise modalities. The mechanism is the amplified AMPK activation and growth factor signaling that the brief, intense demands of HIIT produce, a cellular stress response that exceeds what moderate continuous exercise generates, triggering a more powerful upregulation of the protective machinery, including telomerase. For the morning routine, HIIT is implemented as brief intervals of high effort separated by recovery periods, 30 seconds of near maximum effort walking, cycling, or stair climbing, followed by 90 seconds of easy recovery, repeated for 10 to 12 cycles. Total time, approximately 20 minutes including warm-up and cool-down. For adults with cardiovascular risk factors, medical clearance before beginning HIIT is appropriate and recommended. The third exercise is resistance training, and its specific contribution to telomere biology adds a dimension that neither aerobic exercise nor HIIT addresses directly: the preservation of muscle mass, the reduction of the inflammatory senescent cell burden, and the hormonal environment that resistance exercise generates. Muscle is the largest metabolically active organ in the body. The loss of muscle mass with age, sarcopenia, reduces the production of myokines, muscle-derived signaling molecules, that have been shown to have systemic anti-aging effects, including the stimulation of neurotrophic growth factors in the brain and the promotion of autophagy. the cellular self-cleaning process that clears damaged proteins and organelles. Research published in the journal Aging Cell found that older adults who performed resistance training 2 to 3 times per week showed significantly longer telomere lengths in peripheral blood cells than sedentary age-matched controls, with the effect attributed to both the direct anti-inflammatory effects of resistance training and the preservation of muscle mass that reduces the total scent cell burden the body carries. For the morning routine, resistance training is implemented using bodyweight exercises, squats, push-ups at whatever modification level allows full range of motion, and a plank held for 20 to 45 seconds, producing a full-body resistance stimulus in approximately 7 to 10 minutes. The key parameters are progressive difficulty and muscular effort sufficient to reach near failure by the end of each set. Before we reveal the final 2 exercises, here is a pause. Of the 3 exercises we have described so far, which one is already part of your morning routine, and which one are you going to add? Drop a comment below right now. Your answer matters here, and it helps us understand exactly where this community is and what the next video in this series should address. The 4th exercise is yoga, specifically the combination of sustained poses, controlled breathing, and the mind-body integration that distinguishes yoga from other forms of physical activity, which has accumulated a specific and impressive evidence base for telomere preservation through mechanisms that complement and partially differ from those of aerobic and resistance exercise. A landmark study conducted by researchers at the All India Institute of Medical Sciences, published in the Journal of Alternative and Complementary Medicine, followed adults over 12 weeks of daily yoga practice and measured telomere length and telomerase activity before and after the intervention. The yoga group showed significant increases in telomerase activity and significant reductions in oxidative stress markers, with the telomerase increase specifically attributed to the combined effects of the parasympathetic activation that yoga produces, the direct antioxidant upregulation triggered by sustained muscular engagement, and the cortisol reduction that the mind-body integration of yogi, a practice produces more effectively than physical exercise alone. This cortisol connection is particularly important for the aging population. Chronic psychological stress produces sustained cortisol elevation that is among the most potent known accelerants of telomere shortening, operating through mechanisms including direct oxidative damage, inflammatory cytokine production, and the disruption of telomerase activity by glucocorticoid receptor signaling. The yoga-mediated reduction in both psychological stress and its cortisol-mediated cellular consequences represents a telomere protective benefit that aerobic exercise, while powerful, does not replicate with equivalent completeness. For the morning routine, 10 minutes of yoga, a simple sun salutation sequence or a brief standing and seated pose sequence, provides sufficient stimulus to activate the parasympathetic shift, cortisol reduction, and antioxidant upregulation that the research documents. The 5th exercise is Tai Chi, the ancient Chinese practice of slow, flowing, meditative movement that has attracted serious scientific attention for its effects on cellular aging, immune function, balance, and the neurological dimensions of healthy aging. A study published in the journal Psychoneuroendocrinology compared telomere length and telomerase activity in older adults who practiced Tai Chi with those who did not, and found that the Tai Chi practitioners showed significantly higher telomerase activity and telomere lengths consistent with younger biological ages. What makes Tai Chi particularly valuable as a cellular aging intervention is its engagement of multiple biological systems simultaneously. The slow, weight-shifting movements activate muscle proprioception and the cerebellum, producing neurological benefits including improved balance. The rhythmic, flowing quality produces a physiological response similar to the slow breathing we discussed in our blood pressure video, activating the parasympathetic nervous system, reducing cortisol, and producing the autonomic balance associated with longer telomeres. And the meditative focus required by Tai Chi produces the mindfulness effects on cortisol and inflammatory signaling that research has increasingly associated with telomere preservation. For the morning routine, 15 minutes of Tai Chi, following a basic beginner sequence available through freely accessible online resources, provides the neurological, psychological, and physiological benefits documented in the telomere research. There is a 6th component of the cellular aging equation that amplifies the telomere protective effects of every exercise on this list: sleep. During deep sleep, DNA repair enzymes are more active, the glymphatic system clears cellular waste most efficiently, and telomere repair, the enzymatic addition of new telomere sequences, is most active. A study published in the journal Sleep Medicine found that adults over 50 who consistently slept fewer than 6 hours per night showed significantly shorter telomere lengths than those who slept 7 to 9 hours, with a dose-dependent relationship independent of exercise habits, diet, and other lifestyle variables. For the morning exercise protocol to produce its maximum cellular aging benefit, it requires the overnight recovery environment that adequate sleep provides. The telomerase activity that HIIT and aerobic exercise stimulate is most effectively translated into actual telomere lengthening when the cellular machinery for DNA synthesis is operating in the rested, repair-optimized state that 7 to 9 hours of quality sleep creates. The morning exercises and the overnight sleep are the two phases of a single daily cycle of cellular stress, adaptation, and recovery. The morning routine begins the night before. The nutritional environment that supports telomere maintenance is equally specific. A study published in the American Journal of Clinical Nutrition found that higher dietary antioxidant intake was independently associated with longer telomere length in adults over 50. Mediterranean dietary pattern adherence, the dietary approach most extensively validated across this channel, is associated in multiple large cohort studies with significantly longer telomere length compared to Western dietary pattern adherence. A study published in the British Medical Journal found that each point of increase in Mediterranean diet adherence score was associated with a 1.5-year reduction in biological age, as measured by telomere length. The specific foods most powerfully associated with telomere preservation in the research literature are the same foods we have discussed throughout this channel: extra virgin olive oil, fatty fish for omega-3 fatty acids, dark berries for anthocyanins, cruciferous vegetables for sulforaphane, nuts for vitamin E and polyphenols, and legumes for fiber and antioxidant compounds. The morning exercises extend the life of your cells. The food you eat determines the cellular environment in which those cells live. Let us now assemble the practical morning protocol. The optimal sequence begins with 5 to 7 minutes of Tai Chi or yoga, using the slow, parasympathetic activating quality of these practices as a genuine neurological preparation that shifts the nervous system away from the morning cortisol surge into the balanced autonomic state that maximizes the telomere protective signaling of the exercises that follow. Then 10 to 15 minutes of brisk walking or light jogging, sustained moderate intensity aerobic activity that activates AMPK, reduces oxidative stress, and provides the primary telomere protective aerobic stimulus. For those incorporating HIIT, replace the latter half of this walking period with 6 to 8 brief intervals of near maximum effort. Then 7 to 10 minutes of body weight resistance, squats, push-ups, and a plank. Then 5 minutes of yoga as a cool-down, returning the nervous system to parasympathetic balance and consolidating the physiological gains of the previous 20 minutes. Total time, 30 to 35 minutes. Every significant mechanism of exercise-induced telomere preservation addressed. Every biological driver of cellular aging engaged and counteracted through a specific, research-supported physical stimulus. This morning routine is not a wellness trend. It is a cellular intervention, a deliberate engagement with the biology that Elizabeth Blackburn's Nobel Prize recognized as the most fundamental mechanism of cellular aging. The telomeres at the ends of your chromosomes respond to what you do. They shorten faster when you sit still, under chronic stress, in ways that accelerate oxidative damage and inflammation. They shorten slower, and in documented cases grow slightly longer when you move in the ways this morning protocol describes. The Nobel Prize was awarded for the discovery that aging at the cellular level is not simply the passage of time. It is a biological process that responds to inputs. The exercises in this video are inputs, specific, validated, morning-suitable inputs that engage the telomere maintenance machinery that the Nobel research brought to light. The morning is not simply the start of another day. It is the most important window in a daily cycle for influencing the biological mechanisms that determine how your cells age. Use it. If this video gave you a science-based morning exercise protocol grounded in Nobel Prize-winning research, please support this channel. Hit the like button right now. Subscribe so you never miss a video. And leave a comment below. Tell us which of the 5 exercises you are going to add to your morning starting tomorrow, and what your current morning routine looks like. We read every comment. Your commitment to your own cellular health is exactly what this channel is built to support. Tomorrow morning, start with 5 minutes of Tai Chi. The biology will respond. Thank you for watching. We will see you in the next one.